Hello, this is Mr. Waters, and there was a question, an email question was sent in about number 19 on the homework. Okay, so I'm going to go ahead and show a video of us of working through this one, and I'm going to put this up on Canvas. Okay, so other people can see it. All right, so here is number 19. It says, suppose in problem number 18, oh goody, we have to go back and actually look at number 18. Suppose in problem 18 that the workers were paid $10 per hour for work during the time period from 9 to 5, and were paid $15 per hour for work during the rest of the day. What would be the total personnel cost of the cleanup under those conditions? Okay, so we go back and we look at number 18 to see what all of that pertains to. And it says here that an environmental cleanup, a 2-day environmental cleanup, started at 9 a.m. on the first day. The number of workers fluctuated as shown in the figure at the top of the next page, which we'll get to in a minute. The workers were paid $10. If the workers were paid $10 per hour, how much was the total personnel cost of the cleanup? Okay, so let's see. So that's not a lot of information there. It's just that we know that the workers, I'm going to write it up here. Actually, I'm going to go ahead and put this blank sheet here right under there, and we'll start working on this blank sheet. I may zoom out once we see what's going on. Okay, so let's look at the graph here. And now we see here that the difference between 18 and 19 is that for given at different hours during the day, they're paid different rates. But let's think about the simple version 18 first, right? The workers are paid $10 per hour. Now, we're supposed to calculate what the personnel costs were. So you think about what you would do in order to calculate that would be the number of workers, and more specifically, the number of worker hours multiplied by 10. So if you had 5 workers and they each worked for 8 hours, that's a total of 5 workers, 8 hours. That is 40 worker hours. Yeah? And then, so in other words, you have a total of 40 hours that you have to pay $10 for. So you would take that 40, multiply it by 10, and that would be, so your personnel cost would be $400. Yeah? Okay. So that's what we're getting to here. We want to figure out how many worker hours there are. And once we figured out how many worker hours there are, we would just then multiply that by whatever their hourly wages are, and that would give us the total personnel costs. Well, that's what the graph is for. The graph is for to estimate the total number of worker hours, right? Oops, covered it up. So why does this graph give us worker hours? Well, over here is a number of workers that are being employed at any given time. This is the number of hours. So you can see in terms of what the area under this curve totals up, put in integral terms. I'm going to zoom back out. I'm going to zoom out again now so we can see this. Should follow along on your book if this gets to be too small. Okay. The integral is going to calculate exactly this. The number of workers times the number of hours that they worked. That's what this graph shows. Okay. Where this curve here, let's call it f of t. That curve is the number of hours, is the number of workers there are at any given point during this time period. So that's f of t. Multiplied by the number of hours, which is dt. And then we're going to, so that's what this integral shows us. Number of workers times the number of hours, so it gives us worker hours. Okay, does that make sense? Now, so what we have to do, in other words, is get the area under this curve. right? Now, in the simple version, where they're just being they're being paid $10 an hour at any given time, we're going to sum up the area under this curve from 0 up to 48, right? Now, how did we do that? Well, we just used rectangles. Okay. Now, they've got this conveniently divided into intervals. So I'm going to go ahead and we'll just use the simple 8-hour intervals. Now, by the way, I hope you can read the graph here. This is 9 a.m. the first day, right? And then this is 8 hours later, so that would be 5 o'clock the first day. And then this is another 8 hours. And then this is another 8 hours, and this is 24. This is the beginning of the second day, right? So this would be 9 a.m. the second day, right, to 5, and so on. Does that make sense? When they start, because they're working, we're going to guess 9 to 5 each day. Okay? So we have to figure out when that is. So this is the integral we would do, and we would just use rectangles to figure this out. So we have to kind of decide, here are the time intervals we'll use. Okay? Right? And we have to decide, do we want left or do we want right? Don't matter. Let's use left. So let's see. For left, I'll use the black pen for these. Okay? So the left bars would go like this. Right? And then the left bar here. And then, because we've got to be consistent, the left bar here. Left, 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 like that, right? And then we would find the heights of those curves. You know, we'd add up each one of those, the areas of each one of those rectangles independently to give us the Riemann sum. Right, so this one is 40 workers times 2. This is about 10 workers times 2. This one's about 20 workers times 2. 50 workers times 2. 20 workers times 2. 10 workers times 2. Add those all up. That gives us the number of worker hours, right? And then multiply that by 10. Now, number 18 or number 19 throws an extra curve in. And that is that during each of these rectangles they're not being paid the same amount. So this says starts at 9 a.m. on the first day. So we have to figure out, and it says, and I guess that's going to go till 48 hours. This is 24 hours later. This would be 9 a.m. the second day, right? Would be when, so this would be the 9 a.m. the second day, right? And so this is, I'll write that down in here, okay? This is 9 a.m. the first day, and then 24 hours later, 9 a.m. the second day, right? And then so these rectangles, I'll make them purple. According to the information, during these rectangles, from 9, this is 9 to 5, that's 8 hours, the first 8 hours the first day, and then another 8 hours, 9 to 5, is another 8 hours the second day, right? Just like that. Then the other hours, the other rectangles, are the $15 an hour rectangles. Like that. So we find the area of the purple rectangles. That gives us the number of worker hours for the 9 to 5 period for the 2 days. And then we sum up the green rectangles to give us the number of worker hours for the, the afternoon and overnight periods during the second day, during both days, okay? So let's see here. So let's see. So for the $10, okay, that is 40 times 2. 40 at workers times 2 hours. 40 times 2, that's 80. Oopsie, you can't see that, can you? Sorry. Let me zoom out even further here. Let's see. Here it is. Okay, so the $10 hour period, 40 workers times delta T, which is, oopsie, times 2. What am I thinking? That's 8 hours. That's an 8-hour period, isn't it? So 40 times 8, that's 320 worker hours, right? And then this is for the other $10 an hour period, it's 8 hours difference times 50. So that's 50 times 8 is 5 times 8 is 40. So that's 400 worker hours, right? Okay. And so that's a total of 720 worker hours, assuming, as usual, I did my arithmetic correctly. Now we sum up the other 4 rectangles for the 15, right? For the 15, and then that's going to be 10 times 8. And then this is going to be 20 times 8. And then this one is 20 times 8 again. And then this one is 10 times 8 again, right? So that's 80, that's 160, that's 160, and that's 80 again. And I'm pretty sure that's 32, that's 40, that's 480 worker hours, right? At the $15 rate. Okay, and again, sorry, I'm looking at the paper and not the camera. All right, sorry, hiding that a little bit. So it worked out to be 480 worker hours at the $15 rate. So now we just multiply, right? 10 times 720 is $7,200, and then 15 times 480, that's also 7,200. So we add those up. That's $14,400 are the labor costs, right? And of course, that's only an estimate, obviously, because it's not the exact area under the curve, but certainly it's enough to get on with. Okay, so that's how that goes. All righty. So it's a weird application. So this, I really like this one because we had to keep in mind that it's not one of the speed and distance graphs, but you can see that there's a variety of different areas that this concept of an integral can be applied, right? And so we just had to understand that the units that we are calculating here, worker hours, was given by the area under this curve. And how did we know that the area under the curve was worker hours? Because this is workers, and this is hours. Worker hours. Length times width. Okay, well, all right, that's it, and I hope this is helpful.